and several online courses that we call e-modules. So we have presented the project in the first webinar and the portal. The second webinar was about the first three sets of e-modules that were focused on cartography and spatial thinking, geographical information systems for earth sciences, and applications on earth observing, remote sensing, and satellites. Uh, Today we have the continuation of presenting these modules. So today we will feature map storytelling, coding for urban sustainability, and assessment. So it will be uh, a long presentation, hopefully, and very interesting, where we'll cover the content of these modules. So we have here today, in addition to the nuclear team, which I'm representing, we have the team from Spotting. So we have Alcione here that will present the map storytelling components. So we already see your slides, Alcione. So thank you for being here. And are you ready?
Yes, of course. Thank you, Gustavo, for this nice introduction. And let's make this a really interesting and fruitful evening. I'm Alkione Bagladzir from Spotting. We are responsible within the context of the project, the GeoAcademy project, about the map storytelling module, the map storytelling component. I will quickly go through some slides just to show you where we are, where you can find the module, and how this module is structured. And then we will go really hands-on into the GeoBServe platform and see all the details there. Of course, please feel free to interrupt me, ask questions, raise hands whenever you feel like you need some more info from our side. And we are more than happy to answer any questions you have. So this is the page of the GeoBServe platform. In the GeoBServe platform here at the bottom, you see the eModules button. And also here at the top, we have the eModules menu. Once you press one of those two, you are redirected to this website. Here are all the modules of the project. As Gustavo already said very nicely, some of them have already been presented, so the first three. And today we are focusing on the next ones, map storytelling, etc. And we are responsible for this one. So this is what I'm going to show you during my presentation today and the demonstration of the platform. So map storytelling, the course, the structure actually of the module consists of 4 main courses. One introductory course to set a bit the scene, to explain someone what map storytelling is about, what is the storytelling component, what is the map component, how can I start this in a classroom. So kind of getting a bit familiar with the notion, because particularly for those of you who have already worked with the map storytelling projects, you at the beginning you don't even know at all the concept, but you very easily feel that it can be applied to many lessons, courses, projects you do in your classroom with your students, presenting your students material, or asking students to really be involved and prepare projects. So this is the first one, the introduction to map storytelling course. Then we have the second course where you really get familiar with the platform, the online service we are using for creating map storytelling projects. We have selected one platform. We have their instructions on how you can get access to this platform. It's free for schools and globally, so worldwide. And then we really go step by step with instructions, with videos, with material on how you can really start working and building your own map storytelling project. Then, after setting the base and knowing really the practical part, so the how-to for the use of this technology. The third course comes and gives us the connection to the classroom. So it presents the way we can incorporate map storytelling way of thinking, let's put it this way, into your classroom. This is the how to set up a map storytelling project in the classroom course. And we finished this module. So this module is completed with the fourth course, which is map storytelling examples and applications for the classroom. And in here, we have two main sections about social sciences and SDGs. You get a lot of, let's say, inspiration and related work that has already been done. So each course is then separated in several lessons. The first course has 3 lessons. What is map storytelling, the power of maps, and which are the main components of a map story. The second course has 4 lessons. Introduction to the ArcGIS online platform. This is the platform we are using for creating map stories. Adding story maps online applications, how to. This is all the part of the videos and the instructions on how to use the platform. Adding maps to your story. We have a dedicated lesson on the different ways you can incorporate your maps in the map story. And then we have a last part, the last lesson about sharing story maps and some advanced topics about story maps. This lesson is completed with a quiz at the end. You have to answer some questions, and then the system shows you if you pass or not this course. The third course, how to set up a map storytelling project in the classroom. Here again, we have 3 lessons. How to bring our complex work onto the map, so kind of what we normally describe as modeling. How to design a map storytelling project in or for the classroom, and best practices on how to do this map storytelling projects. Again, here we have a small quiz. It's usually like something like 4 or 5 questions, so it's very very quick, easy, and it's more about comprehending the content you have been learned, you have been gone through during this course. The last course, map storytelling examples and thematic applications for the classroom. Here we have 2 lessons, map storytelling for social sciences, map storytelling for sustainable development. This is basically for inspiration. So we have here story maps that are already published, that are on the web. And there are many, many, many more. And we have chosen some examples. We show you the examples there, that you have all the links, and you have also some description and why each story map is interesting and how it could be used in the classroom. So this is about the theory, and I think now we can really go to the platform and see everything there. Any questions or something you would like to share before I go to the platform? Okay, I don't see any hands raised. I don't see any comments in the chat. So this is the GeoBServe platform, portal.geoacademy.eu. You can also reach the GeoBServe platform via the GeoAcademy website and the button here at the top. And in here, you find the modules. Here are the e-modules, and on the top, there are also the e-modules. So you go to the e-modules, and voila, we see the e-modules of the project, or our project coordinator always says, these are our superpowers. We are going here to the map storytelling superpower, and by clicking on this, we see the different courses that are available in the map storytelling module. The important courses are what you see here with numbered 1, 2, 3, and 4 are these 4 courses really dedicated on the map stories. There are also some additional courses which are related to what we do here. So we also have it here, and we have it also in another part of the platform. It is additionally, so it may be also of interest for you to go through them. In any case, we focus really on the 4 main courses dedicated to the map storytelling concept. And the first one is this one here, Introduction to Map Storytelling. Once you press on the course, you see the starting page of this first course, the Introduction to Map Storytelling. In here, you find some general information, also learning objectives, but you are expected to learn until the end. You see that there are 3 lessons, there are no quizzes, etc., etc. The first time you enter here, you enroll. For doing that, you have to have signed into the platform. And in case you have already started it, stopped it, etc., you will see this continue button here. In any case, here is the part where you start your course. I am just waiting a couple of minutes, and here I see the 3 lessons dedicated to the introduction to map storytelling. So the first lesson, what is map storytelling? You have here a definition, some information, why narratives and why maps, the 2 components of map storytelling. Some extra tips, you can see them usually with this symbol. Here, for example, a classroom example you can do with your students, why this technology is important for you and the classroom, etc., etc. Of course, you can also leave notes, comments at the end. Submit your comment if you like. The second lesson then, the power of maps. Again, the structure is similar. Again, here you have some symbols for some important, let's say, notes, information about the course. And the third part, the third lesson of the module, the main components of a map story. Again, here you have the tips, you have the components, and then how we can implement the map story. This sends you to the next course. The next course is this map storytelling in the classroom hands-on training. This is the main course for learning how to use the online application. This course has 4 lessons. I will just go into it. First, you have an introduction about the platform we are using. Here, also other platforms you can use. We have chosen to work with ArcGIS story maps. Instruction on how to get the license for your school. It's an educational license, so it's free for all schools over the world. Then getting started, your first login. Whenever you see this kind of image, it brings you to a video with instructions, so you can follow it either by text or in a video. Anything you need about learning how to use the story maps is captured in this small, like 2-3 videos. Of course, the most important information are always also captured in the text. So sharing basic functionalities, etc., etc. Then you have the core content of how to use the story maps application with all the information. The main parts of a story map, the cover, the narrative, and the credit section. Everything is also in this small videos we have created. A dedicated lesson on how to add maps to your story map. There are 3 basic ways. We show them all here. You can choose wherever you like. Ideas also for your classroom here. Sharing story maps and advanced topics. How can I make my work publicly available with open links. Here is also the video for that. Some advanced blocks you can use, so advanced ways of creating your content. And at the end, you also have a quiz. 5 questions. You start. Passing rate is 80%. You see, this is a form. You read, you answer, and then you go to the next, etc., etc. And at the end, you get the results. Even if you do something wrong, we provide you with some info about the right answer and why it's right, and I mean the idea behind it. The third course, how to set up a map storytelling project in the classroom. This course is focusing on bridging the two worlds, the technology and the classroom. The first lesson is about maps and how something which is complex, like physical phenomena, historical topics, etc., can be modeled in a way that can be used then as a story map. We have some examples here. We go through the basic questions about what and how to create a map that can then be used. And then we move on to the design of the map storytelling for the classroom. Here we have the 3 main steps that you have to go through with some additional notes and also links to the module of the hands-on training. We have also a lesson about best practices, how you balance your content, how to start, which is best for making it your work readable. We have also prepared here a self-evaluation checklist. You can go through either when you create a story map or discuss it with your students to improve their work, etc., etc. And again, here at the end, we have a small quiz, 5 questions, again, to check that we have understood the content of the course. The last course is about examples and thematic applications for the classroom, 2 lessons. 1 lesson about social sciences, 1 of sustainable development. The idea is to have here story maps, discuss a bit the theme, the description, and the classroom value. We have chosen some examples, both for social sciences and sustainable development. Again, here, the same thing. And at the end, again, here we have a quiz with 4 questions. That was it from my side. I'm also showing you here a story map, like what the end product looks like. You can find all these examples here in this 4th module, and I'm open for questions.
Thank you very much, Kioni, for the presentation. I must say that the module, the hands-on, is very useful because I didn't know how to use story maps, and after doing the module, I managed to understand much better how this fantastic tool works. And in fact, it was very useful also for the students that participated in our map storytelling competition that we just finished.
Happy to hear that.
Good. Do you have any questions? Shana, do you see anything on the chat? I don't think so, right?
No, I don't see any questions, but thank you very much, Alkioni. Very interesting.
Great. Thanks a lot.
Thank you. So I think we should continue because we have lots of ground to continue. There's a message from Lucas on the chat. Is it for us or is just question?
Yeah. No, it's for me.
Okay, good. Thank you. So let's continue with the modules because we still have 2 chapters to cover. So now we'll pick it up. So thank you, Okiani, again. And let me start sharing the screen. There will be a lot of screen sharing now from my side. Just give me some minutes. Okay. So I'm going to just go back a little bit on the presentation because Alcione showed the structure, but it's always good to come again to how do you enter the portal and how you register. So the main website from GeoAcademy is geoacademy.eu, and this is a more institutional site that talks about the project and the partners and its objectives. All the other content, the pedagogical content, is available on the GeoObserve platform, which if you are in the main website, you can access via this hot link on the right, the GeoObserve platform, or you can go directly to portal.geoacademy.eu, which is the main portal itself. So it doesn't matter which direction you come from. Here is where you need to be to get to know better the modules. And there is one small detail that sometimes causes a few problems when people are registering, that you need to accept the cookies. So the first time you visit the portal, you will see a message like this one, asking if you accept cookies or not. So sometimes you have just a reflex of rejecting them. But if you do it, you will not be able to register. So we recommend you to accept the cookies. Otherwise, you won't be able to complete the registration. If you, by mistake, cancel, or if you have any trouble in concluding the registration, you can scroll down all the way to the bottom and go here in cookie policy. At the very bottom, there's this link to cookie policy. If you go here, you have the opportunity to activate the cookies again. You just scroll down all the way and there will be an option to activate the cookies. For me, it's already activated, so it doesn't show up, but this sometimes causes problems when people are registering. So after you accept the cookies, you go to the login page and you have the option to register for a new account. Just follow the steps. And here is another tip. After you fill in your details, you need to accept this CAPTCHA, saying that you are not a robot. If you don't accept the cookies, this CAPTCHA will not appear. So this is one hint that will show you that you have done something wrong, is that you cannot accept it. And below here, there's a picture saying that you need to click, but you don't click on, this is the image, you have to click up here. Okay, so there's some additional information here on how to conclude the registration. After you conclude it, you will receive an email that is to complete the process, and you will activate your account, and then you can start using the e-modules. So I'm going now to stop sharing and sharing again for my second screen, where I'm going to start telling you more about the content on the robotics part of the e-modules. So let me select here the window, which is this one. Yes. Okay, so I'm sharing again. So we have on the GeoHubs part, we have two more items. I'm going to show you very quickly here that we have. No, it's not. This is an e-modules. We have that image that Alcione already showed, where you have all the different GeoConcepts that are part of the GeoAcademy philosophy. So Alcione just presented map storytelling, and I'm going to start presenting now the coding for urban sustainability. And we have two more modules, and now today I'll present the assessment part. So we're going to start with coding for the urban sustainability. So when you visit this part of the portal, you will be taken to the list of all the modules that are part of this topic. So we have here 10 courses. So I'm going to be speeding up through them because we have a limited time to discuss. But this is the list of all the e-modules that involve coding for urban sustainability, coding, and robotics. So I'm going to follow this sequence. The first one that I'm going to present is this 4-part series of STEM education, robotics, and coding. So this is like Alcione's map storytelling course. It's divided in 4 parts, and each part has several lessons. So this very first one, it will deal with topics, the connection between STEAM education, STEAM is science, technology, engineering, arts, and mathematics, with these technological science topics with education and robotics and coding, which is one of the main pillars of GeoAcademy. So the first course, as you can imagine, is a general overview of the general concepts. So we are going to discuss robotics, we're going to discuss its components, and then how do they relate with STEAM. Then you can just expand each one of the sections. So I'm already enrolled in this course, but if you are not, if it's the first time that you are using the portal, you have this button will be there will be a different message. You will be saying start course or something like that. So after you join, then you can do it at your own leisure and conclude it in the allocated time. So I have 2 months to conclude this course, but it doesn't take that much. And after you are enrolled, when you visit the course again, this is the structure that you will see, which is similar to the map storytelling. So in this first course, you'll be introduced to robots and the laws of robotics. So there's a nice mention here to Arthur C. Clarke and Isaac Asimov, who are the pioneering writers of robotics. Then a brief description of the components. Sometimes we think of robots as physical entities, right? Machines, but we also have virtual robots, which is code. So we have different types of robots these days. And this is presented here in the basic components. And further ahead, we discuss the concepts related to STEAM, the STEAM disciplines, and how do they are integrated in 21st century education. And finally, where robotics matches the STEAM objectives and its pedagogy. At the end, you will have a quiz to test your knowledge, and then you can continue to the other courses. I must say that all of these courses in this e-module section, they will use often microcontrollers such as microbit. It is also a feature of the GeoKit that we will be presenting in the 5th webinar, I mean. So the GeoKit is a kit that includes sensors and microcontrollers such as the microbit. So the schools participating in GeoAcademy can have their own experiments using these devices, which are very versatile and powerful. So microbit has many advantages, and one of it is that you can simulate the work of the microcontroller on your browser using a simulator, an emulator, and this is very useful when you are learning how to code for microbit. So, so this is the first module, and is an introduction. Moving on to the second part of this course, we have the part 2, which is about robotic components and systems. So this is a more in-depth discussion of what are the main parts of a robotic system and which kind of systems do we have. So here is the syllabus for this course. Then we have several sections. One of it is about sensors. So sensors, they interact with the environment and provide the data that will be analyzed later using the codes. You have actuators, that is how you make the machines act on something physically. So this is also very important, especially in industry. We have controllers, which are as it's saying here, is the brains behind all of these machines. This is the microprocessor. In this case, can be the microbit. It can be Arduino. It can be code on your machine. These are the controllers. And finally, a presentation to the microbit. So I'm going to show here very briefly the microbit so we can have a look. So this is the standard package for starter kit on microbit. Many schools have these kits in their labs. It's very nice to use. The kids love it. You can do many things with this small kit. And as I said, you can also simulate the coding without the kit. So if you go to the website, makercodes.microbit, you can yourself, even if you don't have one such a kit, you can code and you can see the output just using your internet browser. So it's really interesting. You can see here this kit. This is the main controller. It has an array of LEDs that you can program how these lights flash. It has a speaker, so it can emit sound. It has 2 buttons that you can use to interact with this controller. It has also expansion port here that you can connect more devices if you want to do something more sophisticated. And then here you have a standard USB cable to connect it to your computer. And if you want to take this device outside, you can use this power pack here with 2 AAA batteries and have enough power to make the microbit work even away from electrical power source like your computer. So in short, this module is very important to be able to use the microbits in the future modules, especially in the second set of modules that will present the GeoKit activities. So it's very well presented. If you have any questions, just Shana, I don't know if you're monitoring the chat, but if you have questions or comments, you can interrupt me at any time. I just know moving on because we have a lot to cover.
Yes.
We have here now part 3 of 4 of this first course on cyber education, robotics and coding. So this is, now that we know what robotics and STEAM are, and you know the devices that we can use for robotics projects, it's time for practical applications. So this is very exciting. It's time to put our hands to work. So here we have a good number of examples that we can use using, for instance, microbits. So we have here one exercise to how to control this robotic arm that is called the NETSA. How you can use microbits to control this robotic arm. Very exciting. So we can have an idea of how this kind of device is used in industry, for instance. So now these days, like automobiles, cars, they're all made by machines. We just have a few humans there monitoring, and the robots do most of the work, but these robots must be controlled. So this is a nice introduction to this kind of application. We have another set of activities that we use also the NETSA kit to introduce how vehicle can be controlled by a robot, an autonomous vehicle that we are seeing more and more on our cities these days. We have this very important lesson, which is about having an environmental monitoring robot. So this will start using the sensors. So you can have your microbit programmed to collect data with the sensors and help you monitoring, for instance, sound pollution or air pollution using the sensor. So this is there we have some exercises here that you can check and see how you can monitor different environmental quantities using the microbit. And finally, we have a more complex project, which is how to build programming use an Explore rover. So this is like the final chapter for this section, and this is we can imagine that we can use such a rover to take it to the planet Mars. So we know in Mars we have several robotic rovers studying the planet. So it always starts, having a small prototype at the school, learning how these things work, and then maybe one day your students will be piloting a robot in a surface of another planet. So this is a very nice chapter for practical applications. And finally, the fourth chapter of this series of lessons on STEAM education, robotics, and coding. It's about data analysis and problem solving. So mostly the sensors that these microcontrollers have, they can gather you the data that you can analyze it and having some conclusions about the data that you collected, especially for the environmental aspects of geography. These are very important, especially in these days of climate change. So we have here a discussion about which data collection methods exist and how do you process the data. Examples of case studies. So we have here some types of case studies on how you analyze data. We have a chapter on project-based learning. So this is a very popular student-based approach to pedagogy, where you can involve your students in some projects, and they have a goal that they need to reach. So they will work on how to reach those goals, how to build a project to reach the end of the conclusions, and how can you use robotics and coding to go through this project. And finally, a chapter on robotic competitions. So our partners that are involved in several international competitions, and a few of them are in the field of robotics. So we have, for instance, the Road Robot Olympiad, which is a WRO that is open for schools all over the world, and is a very large event, one of the most important in this kind of activities. And if you are familiar in using microbits and using these kits to control like a robotic arm or a robotic rover, you can participate in the Olympiad, propose a project, and this is very exciting. It's a competition that is divided in age ranges. So you have a competition for the younger students from the lower secondary. You have a junior competition, and then you have a competition for the secondary students. It's very interesting, and this is all presented in part 4. So with this, I cover the first 4 courses of STEAM education, robotics and coding, part 1, which is a general presentation, part 2, which is about robotics, part 3, which is practical applications, and part 4, which is about data analysis and competitions. So we have a few more modules to present. I don't know if we have questions or if we have
now,
comments.
No questions in the chat.
Okay. Thank you, Shana. So let's moving on. I'm keeping my eye on the clock as well. So what follows now, it's a series of modules that will present hands-on activities that were created by our consortium that involves the GeoKit. So the GeoKit is a kit of sensors and controllers that allows the schools to conduct such kind of experiments, be it robotics, be it data analysis, environmental monitoring. All of these can be done using the GeoKit. Each country in GeoAcademy has one kit. If you are from one of our partner countries, please contact your national coordinator to inquire about how you can use the GeoKit in your school. Or if you already have in your school, in your lab, microbits or Arduinos or sensors, you don't need the GeoKit to do some of these activities that are presented in these lessons. So this is also it's very accessible. If you have a few microbits, you can do a lot using these activities that I'm going to present now. So let's start with a very fun activity, which is about earthquakes. So one of the things that we can study with microbits is vibrations, because the microbit has an accelerometer like our own cell phones. It can measure accelerations in the three orthogonal directions, vertical, horizontal, and to the sides. So this we developed this activity to show to students how we can simulate a seismometer using the microbit. So in this particular course, we have a few lessons that will explain how to build this seismometer and how to use it on the students. So in addition to teaching you how to create a seismometer using a microbit, we are also giving some directions on how to use this concept in your classroom. So here we use another methodology, which is inquiry-based learning, where the students themselves will reach their conclusions. So here the teacher works more as a mediator, a mentor in the learning process, and lets the students reach their conclusions and discuss among themselves if what they have concluded is correct or not. So this is, in many countries in Europe, we do face earthquakes. Portugal, where I live, is a country where we have, thankfully, weak earthquakes regularly, but we can measure them. In Greece, is also another region that is prone to earthquakes. So it's in many countries of Europe, you are, especially in the Mediterranean area, this phenomena is quite common. So it's always interesting to show to students how you learn more about them. So in these particular courses, the next ones that I'll be showing, the structure of the activity is presented using a four-step sequence. The first one is presenting the problem and let the students create hypotheses. For instance, here we have some example questions that the students may raise when they're introduced to the subject. So what happens beneath the surface when we have an earthquake? How can we use a small sensor like the microbit to measure the motions of our ground? And if this is sensible enough to detect small movements. So these are the first starting questions that you make your students think about it a little bit before moving on to the next steps. Moving on, we have the experiment itself. So your class has already discussed these main problems and how to use the microbit to create. They can use their own gel kits or their own microbits to create the sensors. There's an attachment here that will show a step-by-step guide on how to create the seismometer and how to code the microbits. In particular, this lesson here needs at least 2 microbits to be executed, because one of the microbits is the sensor itself that will record the vibrations, and this will send the information to the second microbit, which acts the controller and storing the data. So this is all discussed here in the second part. And finally, the third part is about sharing the results and the conclusions with other colleagues. So this is also a very important part in this approach of inquiry-based learning, that after you reflect on the problems, did experiments, reached conclusions, is important to share this with your colleagues. These lessons, they will guide you through the planning of such an activity using the microbits to study earthquakes by building a seismometer with the microbits. And at the end, we have a small quiz. So in short, this is a very good project to have with your students. You can do it in a couple of hours. They will be very happy to build the kit of the seismometer, to code, to see how the microbits can work as a sensor for vibrations. And then at the end, they will be have a better understanding on how the seismometers work in real life. Very well. Now for the second project that is presented here in the e-module sections, we have another very interesting activity that concerns air quality or air pollution. So most of us now live in big cities, and if you live in a big city, you have lots of cars going around, you have industrial pollution, so the air quality is not the best one, unfortunately. And sometimes, depending on the climatic conditions, for instance, when you have thermal inversions, this can lead to deteriorating conditions in the air that we breathe. So it's interesting if you are working in this subject with your students to show them how you can make your own air quality station in your school using a controller like a microbit or like an Arduino. So this e-module is about this activity. So again, we have the same kind of presentation that we had in the seismometer. Also, it is based on the query-based learning approach, where you introduce a problem to the students, they will make questions and create a hypothesis about that particular topic before moving on to the experiment part of this investigation. So after they reflect on what they are studying, how they will approach the problem, they will move on to the experiment itself, which is building this air quality monitoring station with the GeoKit. So this particular kit will use an Arduino, and we have a guide here that shows you also step by step how to assemble this kit. I just checking here if you have if you go to the materials, you have here in the technical reference guide all the instructions that you need to build the sensor, how to connect them to the controller, how to code it. So everything here is detailed in the materials, in the technical reference guide. Same for the other activities. So in the course itself, we have more or less the step-by-step instructions on how to do the activity in your classroom. And in the materials, we have the technical reference, where it is really if you don't know how to use this equipment, if you follow these instructions, you'll be able to conclude it successfully. If you have access to the GeoKit, it's better because everything will be there. If you don't have access to GeoKit, you have a list of components that you can check if you have all the necessary elements to recreate it in your own school. So this was the second course, which is about air pollution and air quality. Now for the third one, this is about a little bit about cartography, so it is also connected to another GeoConcept. And here we use the GPS and GIS to create a pen paper adventure. So pen paper adventure is like a treasure hunt, and it's very popular with students. So this is indicated also for younger students that you can make them use the GeoKit to create a pen paper adventure. Again, you have in the list of materials a technical reference. You can use the GeoKit with the GPS module, or you can use, if you don't have the GeoKit, you can use another GPS receiver, even in your phone. We give here some suggestion of alternatives to perform this activity in your school if you don't have access to the GeoKit. Now moving on to the e-module itself, we have here the structure, the inquiry-based learning structure, question and creation hypothesis, then the experiment itself, and finally sharing and reflecting. So this is, I also like this activity because this involves mapping and involves getting positions. It means that you have to go outside the school to make the full activity. It is something also that the students enjoy it as long as nice weather outside. But it's something that can engage our students and make them work in groups in a different environment outside the classroom. And to conclude here, our set of coding for urban sustainability topics, we have map storytelling through sonification. So now is closing the circle with the first presentation by Alchione, where we were presented to the map storytelling concept. Here we do a mix with the concepts of map storytelling and with sonification. So by sonification, we mean to represent data using sounds. So we are very used to communicating data by visual means, but sometimes audio signals, they are more efficient to communicate some information. And for those who are visually impaired or people who don't have difficulties to analyze visual data, sonification can be a very interesting option. So this particular module will present how you can use, again, the microbit or other controllers in the GeoKit to represent maps and geospatial data with sound. So we have, one more time, a technical reference documents on the microbit and how you can program it to prepare a sonification. So here is the coding structure of the microbit. This is the web interface that you can use to add code. Here's is the simulator that I already mentioned. So you can even do it on your own computer just to test it, but then later on you can upload the code on the microbit using the USB cable and have the controller itself autonomous, and it doesn't need to be connected to the computer all the time. So, so this is the structure of following the inquiry-based learning approach, questioning hypotheses about the sonified maps, then the experiment itself, and finally sharing and reflecting about the results. So after all 30 minutes talking, more or less, Shana, I think I covered all the e-modules on the robotics and coding for urban sustainability section of our portal. So all of these are under this Coding for the Urban Sustainability card. So it's a lot to, there's a lot to do. If you like coding, if you like robotics, if you like microbits, this is the place that you should visit. There are many, many different ideas on how you can use these devices with your students. I'm very sure that your students, those who are into science and technology, they will love it. And there are many other things that you can do with our GeoKit. This is just a few suggestions to easier way in GeoAcademy and how you can collect your own data and improve your skills in coding and robotics. Ready for the final part? Do you have any comments or questions?
No, but thank you very much, Gustavo, for it was super interesting.
Okay, very well. I'm going to stop sharing this, and I have the final part that is assessment, and this is much shorter. So I think about 10 minutes more and we'll probably be done. Just let me find here where the window is. Yes, okay, found it. And let's start sharing the window, this one, yes. Okay, so the final part here of this webinar, it's about the e-modules that concern the assessment of knowledge and skills, how you can use strategies to better understand what is the impact of your teaching activity in your students, if it's improving their knowledge, if it's improving their skills. It's something that teachers do intuitively every day, but it's always good to have some understanding of the logic behind this assessment approach. So this is what is presented here in this 4-part series of e-modules on assessment. So part 1, part 2, part 3, part 4. Let's start with part 1, which is about, is the introductory chapter. So it's about why we should assess students and how should we assess them and how to make this assessment more meaningful, more complete, more comprehensive, because the most important thing that we need to consider here is that every student is different from each other, is an individual which has its own particularities. Every human being is different. We have much in common, but each one is a bit different from each other. And when, as a teacher, you are trying to evaluate the students, if they have, learned, how do you do that? You cannot put everyone in the same box because, as I said, nobody is exactly like the other. So you have to consider their individual differences, and this is what this first module details. Is about the need that we have to assess our students. We all have been to school here. We did tests, and we had grades, and we have to have a minimum grades, and you go to university, it's the same thing. But why do we do that? Why do we have tests, and why do we have grades to measure your competences and your skills and your knowledge in different subjects? So this is are the topics of this first part. So it's the introductory chapter about the very concept of assessment learning. Moving on to part 2, this is now that you know why do we need to assess our students, is how to consider the individualities and the special needs, what's behind each student. You don't know if they had a bad day at home, what is troubling them. All of this has impact in the learning process. If you go to a classroom, you see the students are more active, the others are more quiet. There's the guys that sits on the back of the room. There's the shy student. So each one is a universe in itself, and we need to have how to weight these individualities on our assessment approach. So it is what the second lesson will cover. So how to integrate the diversity of our students in our assessment practice, and also how we use the universal design for learning in making our efforts, because when you are teaching, you are giving a lecture to a class, you have to address everyone at the same time most of the time. So you must deliver something that is general, and you try to reach as much people as possible, but there will be times that you need to go to each specific need and work in more individually with these students. So this module covers especially the topics of inclusion, diversity, and the universal design for learning, on how to make you a better teacher in terms of reaching most of your students' needs in your practice, taking into account, of course, how you are going to assess them later. Now to part 3. This is about the student-based, student-centered education. So as you've seen in these presentations, we use different student-centered approaches. We have project-based learning. We also have inquiry-based learning. But what is pedagogical approaches have in common is that they are focused on the student, and then we want the students to being also build their own knowledge, not being just recipients of the teacher knowledge, but also interact with their colleagues, and everyone together have a collective knowledge production, and also improve their skills and the competences. But for that, when you are assessing this growth in these capabilities, we need to know how we are going to divide. How do I assess competences? How do I assess knowledge? How do I assess skill? So sometimes this can be a bit confusing. In this chapter here, it discusses exactly this. Uh, how do you assess these different aspects of the learning process? Because, knowledge is different from competences, which are different from skills. So it requires a bit of care on the assessment strategy that teachers use, how to efficiently assess each one of these different angles of the learning process. And finally, the fourth and final chapter of the assessment e-module will cover the two big types of assessment that we do in education, which are the formative assessment, which is the assessment that we do during the learning process. So it is a continuous effort, class by class, student by student, you follow their progression, with the summative assessment, which is usually done at the end of the process. And this is, at least for us that are older, this is the more the idea that we have of assessment schools for the old guys like us, is to have a test at the end, and you have to have a minimum grade to pass the course. So this is the summative assessment, but is not by a close chance the only kind of assessment that we can have during the teaching practice. In fact, there are important differences between the test, and you're asking questions to the student, it needs to answer and give correct answers for the summative assessment, from the whole process of every class the student participated, and what he or she learned during all this time that it spent on class. So this final assessment module, final assessment e-module is on formative and summative assessment, and will hopefully help whoever is taking these courses how to be you know, have a better understanding of everything that is involved in helping our students to learn the better way possible, because I think this is our goal here as educators, and especially in GeoAcademy. We want to make the teachers better teachers so they can teach best to the students, and the students will learn more and learn in a more meaningful way and carry not only the contents but also competences, skills, and be better human beings when they leave school. So this, I think, is the main goal of this project, and in particular on the assessment e-module is how we integrate this in the teaching practice. And I think I'm done, Shana. I think we covered both sets of e-modules that I needed to present. I see Lucas there. So Lucas, do you want to make any comments, additions? I don't know if you enjoyed it.
I really enjoyed it. One-woman show for Alchione in the beginning, and it was amazing. And one-man show now. You both presented everything in detail, and you said everything. I mean, the GeoObserve platform is the main driving force of the project. All e-modules that we have now presented last week and no, 2 weeks ago, and this week include everything. Not only training, but especially educational activities, lesson plans for formal, informal, and non-formal education. So yeah, we enforce the teachers to take a look on the platform, to different courses, to lesson plans, to test them. And please send us your feedback, because it's really, really important and crucial in order, to make everything better or to make everything work, because we have a vision, that's true, to embed and link geospatial technologies with education for sustainable development, but it's not always that easy. However, because we have this webinar series and we are still conducting trainings, we are still expanding our activities. Not even Gustavo, Sana, and Alchione know that, but we are working at something at NTUA on how we